All right, everybody, this week we're going to start doing a little Oxy Fuel torch cutting. Then we're going to transition off to brazing. So let's look at tank setup first. That's fairly important. See, Oxy, this is a acetylene tank down here, and I can't get it to rotate, but it is where it is. When you're turning on a tank, I like to turn on the oxygen first, and that's because if I have an issue with some kind of fuel or anything, I can always blow it out with the oxygen. So fairly important. Got the valve here to the tank. Got a gauge here. The one closest to the tank is going to tell us how much pressure is in the tank. This is an idea of how much volume we have. Second gauge here is line pressure between Mickey Mouse's ears. This little valve right here. So let's walk through this. First off, when you go turn on the oxygen tank, just barely turn this thing on. You see that pressure comes up? You don't want to have the regulator open already, so you want this one to stay at 0. Barely turn it on. Once it's on, you go ahead and reverse seat this thing. And all that means is that you open it all the way up, and then once you're all the way open, you tighten it. Now these bottles come in 25, 26, 2700 PSI, 100 PSI. So right now we're just about 2000. It's important to just tighten this when you reach the top. That's called reverse seating. Tighten it so it doesn't leak out on us. Now, really key here, this regulator and this gauge turn the exact same way. So it's kind of counterintuitive to most people when they first start. This is the same way that compressors run, everything else, but I'm going to turn this. And for cutting today, and I like to just lightly tap on the gauge. For cutting today, I want to have a good 40 PSI. The process we're going to show you today is called rapid oxidization. Now over here, down the bottom here, this is our acetylene tank. It's always a little smaller. Acetylene tanks can be fairly dangerous. We want to always have our tank strapped down, as you can see. Acetylene is one of the few of the fuels that if we get a fire back in this bottle, it'll blow up. That doesn't happen with a lot of the other fuels, but with this one it does. And that's due to its porous construction. Starts off as a fluid in there, comes out as a gas. Now we're just barely going to crack this valve, crack it, and then give it a full turn, turn and a half. Make sure the gauge comes all the way up. And then it's very important here, you see this little red spectrum here, this little red don't go into. You never want your pressure above 15. 10 is good for us. We have to get past a burn back arrestor and some other choke points. So 10's good for cutting. Usually I run about 5 to 7 when I'm doing any kind of torch work, as far as just heat, not cooling. But 10's pretty good for the amount of fluid we're going to need now. So the tanks are all set up, we're ready to go. Got my gloves right here. Gonna come on over. Looks like we don't have an igniter, so I'm gonna fish around for an igniter apparently for a second. Boom, 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 boom. There's a couple of igniters right there. Tip cleaner, any number of things. All right. When you get to the table, it's important that you don't go setting things in a way that they can fall all the way through. So we'll have a little sub table here. Now what we're gonna do is we're gonna cut off a couple of pieces of bar stock. Just to show you the cutting procedure, I can go with some longer ones, 5. We'll have you cut in 2s because then we'll have you use that material a little bit later. But let's start with the 5 and just talk about the torch. First off, check the trigger, make sure it works. Check the valves, good, good. I usually sniff around the torch, make sure I don't smell any leaks. Gonna go ahead and just barely turn this valve on. Maybe a quarter of a turn at the most. Kick it. Boom. This is a number 1 tip. We want that so it's touching the torch like that. You see how this is too much? We want the torch set up so that we have the most heat without the black smoke and still touching the tip right there. So that's just a fuel flame only. We put this on the deck. That's just gonna leave some partially digested acetylene on the deck. Not a very useful flame unless you want to soot something up. Back in the day, we'd take them like this, and all this little smoky mess we'd let get on the side of our panel vans, and that was a known custom effect for painting. But we don't do that so much anymore. So that's a fuel flame. As I start to give it oxygen now, barely slowly dial this thing up, you can see this whole flame goes bright white. Bright white, that is a carburizing flame, like your carburetor on the old cars. Carburizing. We can use that flame, if something's really hot, we can use that flame to add a little carbon content to our plate. We're gonna dial this flame all the way down to the point where we see that blue flame, and just to the point where the codes is tightened up, And then I back it off just a little bit to have a little haze on one of them. Just very softly, and that's called an acetylene finger. That way you know that you're not oxygen rich. The most powerful is if you can tune it just appropriate light there. This is a neutral flame. That's when we are hoping we have full combustion. So we have a fuel flame, carburizing flame, whoop, and an extinction. This tip's got a little debris in it. I'll show you how to clean that out in the next video. So fuel flame, carburizing flame, neutral flame, and then finally this trigger here, we're going to shift the torch into an oxidizing flame. Oxy fuel cutting is done by first heating up the material. You can see I have this torch. We're going to keep it an inch above the deck. So first, just heat up the material, just the edge. You don't want to do a penetration here, just the edge. And let's come over here so we're not wasting a whole bunch of material. Just the edge. And then when it gets to an orange hot, you squeeze this trigger here, and you burn through the material. Just like so. Start here, get a nice straight slant line for ourselves. Keep that torch an inch off the deck. Now this process uses pure oxygen. We take the iron to its cutting temperature, to its kindling temperature, the point at which something wants to start to burn, and then we burn it. We throw pure oxygen on the fire, and away you go. That's a pretty crooked cut. Let's try getting that a little bit better with our cutting guide here. And just rest this thing alongside of it. Boom. Make sure you have some way to slide this torch. I always do the pull hand. And remember, at all times, keep it an inch off the deck. There is nothing physical on the tip of the torch that's going to make it cut. So having it down against the plate is only going to jam up our torch. Gloves. Make it go to a bright orange. Squeeze. Just put it against our guard here. Bright orange. Squeeze. Get a nice pace. As long as you have debris coming out of the bottom, you should be pulling along. Moving nice and smooth like. Just like that. Bit of a straighter edge there. Let's do another one. You don't want to cut right on a guard because they'll just blow debris all over your face. That's not really nice. So we're just like so. Put it up against the guard and cut. This is a very common process for cutting heavy material. Oxy fuel has a greater potential, meaning it can cut a lot thicker material using the chemistry of rapid oxidization. That's how you say burning. We are rapidly oxidizing, or we are burning the iron out of our joint. Oop, just like that. Nice and smooth. Start the orange. Keep it an inch off the deck. Balance the torch on your other hand here as I'm doing. Cut yourself a couple of ribbons. Debris, sparkles coming out of the bottom. Nice, smooth, easy going.